In our last video in financial math, we're going to talk about the amortization of a loan. So to determine the monthly payments required to pay off a certain loan amount, we may use the present value of an annuity formula. So we're not going to introduce any new formulas. We're going to use the same one, or actually there's two equivalent ones, right here. The difference is that the P is now the amount borrowed. It's the amount of the loan. Because I may have mentioned you can think of a loan as an annuity. If I'm a bank, I may give you $100,000 to buy a house, but you're going to agree to pay for the next 30 years, once a month, you're going to give me a payment to pay that off. So that loan is like an annuity. So, in the amortization of a loan, the amount borrowed P is related to the periodic payment amount R by the same formula that we've already used. So just remember, when we're talking about loans, we use the present value of an annuity, and the capital P is the amount of the loan. So R is the same thing as it was before, periodic payment. For a loan, and by the way, if we're talking about a loan like a car loan or a home loan, if it does not mention it in the problem, you are going to assume that the payments are made monthly, 12 times per year. N is the what? The total number of payments. I could have said periodic payments. For a mortgage, if a 30-year mortgage, 12 payments per year, 12 times 30, that would be 360 payments. N would be 360 on most home mortgages. And then I is the periodic interest rate. So what that means for our home loans and car loans is you take the annual interest rate and you divide it by 12, because there will be 12 payments per year, once a month. All right, and then P, as we've already said, rather than saying the present value of the annuity, I'm going to say the amount of the loan. Okay, well, let's look at a couple of simple examples and we'll be done with this section. All right, Mike obtained a 2-year car loan that required monthly payments of $366.64 based upon a 4.5% interest rate. How much did he borrow? That means how much was the loan? In other words, what was the capital P in this formula? We know the R, and we can compute the I and the N as well. So we're looking for, let's read through it one more time. Mike obtained a car loan, 2-year car loan. So if it's a 2-year car loan, and remember what a car loan is paid once a month. So what is our N going to be? How many payments for 2 years? Monthly payments, so it'd be 2 times 12, or 24. And let's see what else we've got. Monthly payment, well, the monthly payment or periodic payment is always capital R. And it's a 4.5% interest rate, which means R is 4.5 means 4.5. 0.045 when written as a decimal. 4.5. So what does that mean I is going to be? I will be R over M, which is 12. That's going to be 0.045 divided by 12. And let's see what that is. That turns out to be 0.00375. So that means this number as a percent would be 0.375% each month. And those 0.375%, if you multiply it by 12, you get the 4.5%. So every month, the periodic interest rate is this. I think that's about all we need to plug it in now. I'll write the formula down again. It's P equals R times 1 minus 1 plus I to the negative N over I. And again, I'm using my favorite formula, using this one instead of this one. You can use either one. All right, so that's going to be, the periodic payment was 366.64. And then we have 1 minus 1 plus I, which is 1.00375. And it's raised to the negative n power, number of payments, and that was 24. So negative 24 all over I. And I is 0.00375. So that means our P is equal to, if we plug it in, 8399.96. That is the loan amount. P equals that. Now, what do you think about that number for a loan amount? Do you think you really got an $8,399.96 loan? My guess is the car cost $8,400. But there's small amounts of round-off error. So we're only 4 cents off, but this is the correct answer based upon the information we were given. All right, let's look at the last problem. An employee borrows $8,000 from the company credit union to purchase a car. The interest rate is 12% compounded monthly. That's nice and easy. That means 1% per month. The loan is amortized over 3 years, so it'll be paid off in 3 years. How much are the monthly payments? And I'm reminding you that we're looking for R. In the previous problem, we were looking for the loan amount. But what do you think this is? That is the loan amount, the amount that's being borrowed. So in this case, we're given P and the interest rate and everything else, except for the monthly payment. So with the same formula, but we're going to solve it for capital R, the monthly payment. Okay, interest rate, 12%, so that would be R is 0.12. Let me just write over here that I would be 0.12 over 12, which is 0.01. 1% per month. And then N, what do we need? What do we know about N? Okay, it's 3-year loan. That's the number of years times 12 per year, 12 payments per year. So N is 36. I think that's all of the variables except for capital R, which we'll solve for. So we're going to have P, which is $8,000. $8,000 is equal to R. That's what we do not know. And 1 minus 1 plus I would be 1.01 to the negative N. N is 36 over 0.01. So that means that, I'm just going to write it a different way, R is equal to, I'm going to divide both sides by this big bracket. Divide it, this one and this one. So R is going to be 8,000 over that big bracket. 1 minus 1.01 to the negative 36 over 0.01. And if you plug that into the calculator, you get R equals, I'll put the dollar sign, $265.71. So we used the same formula, but solved for a different variable. So an $8,000 loan from the credit union that has a 3-year duration is going to cost $265.71 per month to pay it back.